Hey everyone, welcome to another We3Live installment. We've got a great episode for you today with LF Energy's Executive Director, Dr. Shuli Goodman, just an expert in open source energy solutions. Really excited to hear the discussion, and so I will pass it off to SEW's CSO, George Hunt. George, take it away.
Thanks very much, Dylan, and welcome, Shuli. I'm just going to provide a brief introduction and then let you follow up with it. But you've got such an amazing career, and it's so fantastic to have you with us today. But let me just introduce you on your behalf, if that's okay.
Thank you.
So, Dr. Shuli Goodman is the founder and executive director of LF Energy. LF Energy is a really interesting company, which is part of the Linux Foundation project, and it supports open source innovation in the energy and electricity sectors. And the ambition is to accelerate the energy transition and the decarbonization of the world's economies. So having spent the early part of her career enabling some of the world's largest companies in the world to become internet ready, Shuli has now brought her digital first cross-industry background to the electricity sector, and with the backing of the Linux Foundation as well. Shuli has a doctorate in organizational systems focused on innovation and energy transition. This provides a uniquely multidisciplinary approach to solving complex interdependent problems, which is something we're going to talk about today. Shuli has nearly 3 decades of experience in the startup sector too, providing governance and support to multi-stakeholder engagement bodies, convenes to enable decision-making and steering for high visibility and high-risk initiatives. Again, a fantastic platform for what we're going to talk about. Just before I hand over to Shuli to say hi, the goal is to inspire, train, and enable 10,000 developers in the next 10 years to digitally transform the world's power systems. A truly ambitious and exciting prospect. Can't wait to hear more about it. So welcome, Shuli. It's a real privilege to speak to you today. How are you doing?
I'm great. Thank you very much, George. It's wonderful to be able to talk with you today.
This is a fascinating topic, I think. It's a topic that we don't get to hear too much about. So I'm really keen that we use this as a platform for LF Energy in particular, and also, a platform for the Linux Foundation and how it's transforming. So we'll see how the conversation goes. But I'm really keen that we get sort of deep into the real nuggets of what makes the difference here. So, however, as is tradition with the We3 platform, we'd like to start off with a bit of a speed round.
Okay.
So the mandate
I'm
for
ready.
the mandate for this is short, quick answers. So here we go. All right, first one. There's 4 questions. So first one is, so did energy find you, or did you find energy?
Energy found me.
Okay, can you explain a little bit more how? I know it's meant to be quick.
I didn't know how short you wanted to be.
Yeah.
Well, I think that one of the things that's most remarkable to work in energy and power systems is that the word energy and power have multiple meanings. They have symbolic meanings as well as meanings that are kind of grounded in physics. So the notion of energy and having in particular good energy or thinking about how we manage energy is a journey that I began on very young in my career, in my life, not even my career, just, really as a 20-year-old thinking about, well, what's energy and what's good energy, and how do you show up in the world in a way that actually attracts people and creates more love and peace and well-being and calm in the world.
I really like the concept of good energy, and it leads me to think about bad energy as well. And we won't go down there today because we're looking towards the future. But the fact that we're opening up the topic of good energy is I find quite exciting. So okay, next question. What advice would you give to a young you just starting or entering your career in this field?
I was thinking about that this morning. I mean, the first thing I want to say is put your phone down. And the second thing I want to say is go out and learn about natural systems and learn about how natural systems are replicated over and over and over again, that the world that we see manifest around us is a response to 5 billion years of evolution. And so we think we know what life is. We think we know what energy is. We think we know what power is. But in many ways, those are just constructs of the mind. And so, you know, if you're beginning your career, put your phone down, go out into the natural world and learn about it. Understand what makes things grow, what makes things not grow, and how do complex systems work together.
Oh, I love that answer. The concept of natural systems and you know, nature is such a wonderful thing, and I think there's a lot of activity going on about how we leverage nature and how we actually protect our environment as well. So yeah, I love that answer. Fantastic. Third question for you. What would you put on a billboard for 7 billion people on Earth to see? If you had the option to put something on a billboard, other than put your phone down to the younger people in particular, but what would you put on that billboard for 7 billion people to see?
Well, I also thought that was a great question. I loved it. And so I kind of cycled through a few of them, a few ideas. But the one that I kind of landed on is actually a question, which is, what did you do during the Great Transition? And the reason why I think that this is important, and I often start my talks with this question, is that I believe, you know, I think Einstein talked about the mind that creates, and that one of the things that I believe we have to recognize is that the systems we are trying to transform were conceived of during a time where manifest destiny and the domination of people and systems and nature and everything was legitimate. It's kind of like, well, that's what nation states do. That's what rulers do. But we are going through a fundamental transformation. And so the notion of great transition came to me in an imaginary conversation with my unborn grandchildren. And this was about 17 years ago now. And they said to me in this imaginary conversation, you know, you're walking along and all of a sudden, boom, there's like a bolt from somewhere. And they said to me, what did you do during the Great Transition? And that question really has animated my life ever since.
What an amazing answer. You're kind of making me think now as well about, you know, what you know, if I was asked that question, what did I do? I'm kind of also asking myself, what can I do today, or what should I do today, and what, you know, as a citizen of the planet, what should I be doing? So, wow, that's a fantastic answer. All right, one more, and then we'll get into the detail more. There's one more. So what?
This is my favorite one.
Well, I'm stealing it now. I'm stealing it. So, tell me something that you believe in that other people might think is crazy.
Okay, so this is where I get to really talk about what animates me. So I live in a rural place, and I live and I have these amazing trees and forests that I live in very close relationship with. And as I have been working really intensively in the last 4.5 years to understand what power systems are, how do we transform them, how do we actually envision what our future needs to look like in order to meet the needs of the people who inhabit the planet and the other, the other life that inhabits the planet. I believe that the grid of the future is not a grid at all. In fact, I think that it's going to be closer to a forest than it is to a mechanical system based on 90-degree angles. And that's the reason why we named one of our software projects, the microgrid project, HIFI. And HIFI are the communication filaments underneath a forest that connect trees. And so trees are extremely efficient at managing energy. for the whole system, not just like, you don't look at a forest and go, wow, that is an incredible Elon Musk. And wow, did you look over there and take a look and see there's an amazing Bill Gates over there. And wow, that ghetto, I'm really sorry about that ghetto, but it doesn't work that way. The trees bring down the energy and then they use it, but they turn it into sugars, which they then transform and push out into their mycelium networks. And they use hyphae to communicate that so that the whole forest is healthy. And that's how I think about the power systems and the grid of the future.
That's a really nice fusion between energy and nature, I think. The fact that the fabric that we think of today is a grid. We think it's an interconnected grid, as opposed to a fabric, and it's a new word for me, hyphae, but as opposed to there being a fabric that sits underneath. Actually, the fabric is actually the way in which the system keeps together and the system keeps healthy. I think that's a really important concept for us to think about today in our conversation, because I think some of the open source philosophy is really about how do you create interoperability below the mechanical layers, and we can probably explore a little bit about that. All right, those are amazing answers. Thank you for that. So we'll get into a little bit more detail. I mentioned at the beginning, I'm a real advocate of open source. I'm a real advocate of open ecosystems where great things come together through collaboration. And I know that the tagline for the Linux Foundation is stated as decentralized innovation built on trust. It's a tagline I've seen them use quite often. I'm interested in, as we sort of get into our conversation today, what does that tagline mean to you? So decentralized innovation built on trust, before we get down into sort of a little bit more about LF Energy.
Well, yeah, that's interesting, because I thought you were going to say the tagline of LF Energy is the power of together. And I think actually that there's a very high degree of connection between those two things. So what I think that the Linux, so my PhD is in the adoption and diffusion of innovation. And the question that I asked is, during times of collapse, how does the future emerge? And the reason why I did that, it was I wanted to understand why we're not moving faster. What is making it so difficult for us to transform our systems? So when I was thinking about this and I was looking at how slowly we were moving, I started to think about governance and how it is that we govern complex systems. And while I think, and I think that the Linux kernel is one of the most remarkable examples of human cooperation ever. And it's very lightweight. It's it's totally decentralized, and it's based on relationships, and it's based on a duocracy. It's based on a contribution of good stuff. And if you do that, then you move in, in the concentric circles in terms of being able to do things together. So there were no politicians, nobody was killed, there were no guns, and it went from a dorm room in Helsinki to being, the operating system of the planet. And basically that same philosophy is templated. And there are now, I think, 475 projects, and and growing, and so it's not slowing down, but it's really decentralized trust. And it's based on governance, and that governance framework enables transparency. And so what the Linux Foundation is essentially is a pre-competitive platform.
That's fantastic. I love that idea. I really like the idea of collaborative activity based on something that is collective goodness from a whole range of contributors, and the way that it breaks down barriers. I'm I'm going to ask you a little question now about. I did some research about how open source has transformed other industries like telecommunications, travel, finance, and others. And when I was doing that research, McKinsey and Company described open source adoption as being the biggest differentiator for top quartile companies. So the concept of a software-defined vertical industry is also really interesting. So I'm interested in what you think those concepts can do for the energy sector.
So that report that got, I don't know, I guess it came out about 6 months ago. I think it's really brilliant. And what we did at the Linux Foundation was initially, the projects at the Linux Foundation were all very technology centric. In other words, you have blockchain, you have the kernel, you have embedded Linux, you have Node.js, you have cloud. And so there were things that were kind of core infrastructure technology that could then be applied in a gazillion sort of use cases. But in the last 5 years, and I think that it was really driven, by two different things. It was driven on the infotainment side of transportation, them saying, well, hold on, everybody's walking around with one of these, sort of snapped to their car. And why don't we build a better mousetrap that's kind of inside the car? And that became a pre-competitive cooperation. And then the other one was around 5G and telecommunications. AT&T recognized that they were going to be moving towards 75% software defined. In other words, virtualized. And they got about 25% of the way there, and they realized that they absolutely could not do it alone, that it was too big of a lift. But it took, because they were so far ahead in sort of on the wave, it took a while for there to be others who kind of came to recognize that in fact that was the direction, that they were moving from hardware, black boxes, proprietary, to software-defined infrastructure, which gives us 5G. And we could not have the edge, we could not have 5G, and we could not have the power systems that we need in the future, and transportation systems, if it was not for this entire software-defined infrastructure. So there's been this evolution that has happened in terms of moving from core technologies into industrial transformation. And I think that the parts of the power system networks of the future, distributed computing, which is cloud native, moving from monolithic software into microservices, continual integration, continual deployment environments that allow for much faster iterative, that's critical to power system transformation. We can't do this another way. The transportation systems, vehicle to grid. I mean, everybody, we're all looking at the batteries in cars and going, oh, that's a really great resource. And in many ways, what batteries in cars and batteries in laptops demonstrate, they are basically microgrids. Okay, they plug into the grid and they can provide a resource back to the grid. They are a load, but then they can move away. And we actually have to start designing all, or as much as possible, of our big loads as both a resource and a load to the grid. And so we are in the very beginning stages of really rethinking fundamentally sort of what a microgrid is. I don't think it's these massively complicated systems. I think that, you know, a car is a microgrid as it's defined by IEEE. A laptop is. Anyway, so software-defined infrastructure and verticals. This is how industries transform. The reason why the Linux Foundation is a pre-competitive platform is because rather than rearranging the deck chairs on the Titanic, we need to actually change floors. We need to get off the boat. We need to, whatever your metaphor is. We need to be able to move at the speed of technology. And so you have a grid that is managed by inertia, and that inertia exists in our organizational systems and in how we balance the grid. And in order to move forward, we have to come up with a whole new sort of infrastructure, a whole commodity layer of technology that allows us to manage a low inertia grid and continue to balance the grid. And that is really requires radical electron efficiency. And it requires us rethinking entirely how the grid is managed and operated and networked and choreographed.
Wow, what a fascinating answer. I found myself thinking a lot as you were doing that about the fabric under the trees that you described at the beginning, about, you know, how microgrids come together, and there needs to be a fabric that binds them, and that fabric needs to be open and interoperable.
Exactly.
I also really like the fact that you know, what you're proposing is very transformative for some of the challenges that we face. I'm interested in what you think some of the constraints are. What are the things that get in the way of adopting and accelerating the innovation around these things? And I'm thinking along the lines of regulation, about monopoly companies, or rather competitive companies protecting their market shares. I'm thinking about cybersecurity as another one. And we've got a question from the audience around, is there a misconception about open systems and cybersecurity? So I'm really interested in what are some of the things that you feel are inhibiting progress here?
Well, this is like really closely connected to the cyber issue. So there are cybersecurity, there are technical aspects of it in terms of being able to, so if we're building a system that is beyond our intellectual capacity to manage, and I would have a hypothesis that that's what we're doing, that we have to begin design. The issue of cybersecurity, it's more of an architecture and a framework than it is a silver bullet. And what I mean by that is that there's a whole software life cycle. So there's this like a software supply chain life cycle. And we have seen multiple failures, at least in the US, related to that supply chain failure, which is the reason why Biden put out that executive order, which was driven by supply chain security. And so, but I think we have a lack of understanding that software, even though it's intangible, has many of the same requirements of a supply chain that we have to build in order to ensure cybersecurity. So I personally believe that given that we're moving towards a global brain, and that's, you know, kind of how Microsoft sees it or how Google sees it, that what we are doing is creating a kind of digital infrastructure. No one company should own that. That's wrong. I mean, that will be bad for nation. It will be bad for humanity. And so instead, what we need is a kind of governance, and we need to have a life cycle model. Now, you know, I am really a social scientist as opposed to a, you know, I mean, I'm not a power systems engineer. I'm not a physicist. And I have a very strong belief that to design the power systems of the future, we need to have multiple disciplines engaged. And when I look at the problem, I think that there are many extremely important technical challenges that we have to um, address moving forward. But at the heart is a human transformation. And so we have regulated entities in which you have public utilities commissions or regulators who really don't know much about information communication technology. And then you have utilities that have been essentially denuded of their capacity for R&D, for development. And so where everything is, rate-based, and so they outsource everything. And I think that those are really huge problems. That the inertia of the grid became the inertia of utilities, regulators, of of, of the utilities themselves. And so there's this whole process of transformation that needs to happen. And I think it's the bigger part. It is the core restraining force. That at least in the US, we've never had a successful rate case around cloud, yet there is not the slightest possibility on the planet that we can transition to electric mobility without that. It's just not possible. And there's no mechanism for it. And the cost, well, I guess there might be a mechanism for it, but the cost would be so exorbitant. And that, part of why people went to distributed computing and cloud was to decrease costs. So it's like you're kind of shooting yourself in the, so we have these very big political requirements, and we do not have a regulatory environment that's able to move it. And we have organizations that fundamentally have to transform themselves to become technology companies. And if they don't, then I have to tell you that I think that the smartest minds I know in energy are Google and Microsoft. So I look at it and I'm like, well, I don't know how it's going to work, but the network of the future, power system network of the future, is not what it used to be. It's going to be closer to managing a network like the internet. And the word hyphy, by the way, means web in Greek. So we are creating a web, an energy web.
Wow, what a fantastic takeaway that is, because as you were talking, I was thinking to myself, could we build the grid, the system of the future, as one question. Then I thought, if we could build it, could we operate it? And then I started to think, will the regulators allow us to build it? And then I thought, well, who's going to step in and overcome the inertia associated with all of those things? And I think you've answered the question for us, which is actually the paradigm shift here is we've got to make a shift from thinking about it as an electrical grid to actually an internetwork of interacting components, if you like, or devices or assets. I can't believe how fast the time has gone, but I wouldn't mind asking you two more quick questions in the time we have left. One is, I'd like to give you the opportunity to talk about a few of the projects of LF Energy and where anybody listening to this conversation, where they could go to find out about those. So that's my first question. And the second one, which maybe you can think about as you're answering the first one, is what's your call to action? I'm really keen that this is a good platform for you to share. What do you think should happen next in order to perhaps overcome the inertia? So, I'm really keen to hear about the projects and a little bit about where people can go, and then a little bit about what are your final words about what we should do next.
Great. You're a really good listener. Thank you. Okay, so along the first lines, we've tried to make the website as logical as possible. and to put all the resources there. And this past year, when we did a refresh of the website, we also really put in a wiki in the back end. And so if you go to the website, you can then go, you'll see under the links of the project, you'll see wiki, GitHub, mailing list, YouTube. And so all of the resources are there. Go to the wiki and you'll see sort of how we're relating to security and core infrastructure initiative. And, I'm constantly on folks, to make the wiki as alive and vibrant and relevant as possible so that people can drive by. Every single project at the Linux Foundation is open. You do not need to be a member. The reason why you want to actually pay membership dues is to support the head gardener and the assistant gardeners of the ecosystem, and also so that we can continue to go out into the world and tell the story and the narrative, which gets to the second one. So there are a couple of really important projects that have come in, and I have 2 more that we've just adopted, and another 5 or 6 that I think maybe by the summer will begin to come in. And so what I'm seeing happen is that the software is really becoming more interdependent, and we're really working at both the transmission and the distribution level and at the interface between them. So I'll talk at the transmission level. I think that Possible, which stands for Power System Blocks, is an unbelievable tool that's quite mature to be able to model and show your grid all the way down to the substation level. And I think that this tool is amazing. And with open source, what you want is to start with something that's good enough and then expand it. So I would love to see it expanded so that Possible actually at any given moment in time, a network operator at the transmission or the distribution level could see what is happening in their network using Possible. At the distribution level, GXF is what the Netherlands uses to manage their head-end system into their meters. It's like an IoT fabric, and it's also being used for parking garages, for charging, and for lights. So it's an industrial tool for a distribution utility to manage resources that are hanging off of it. I also would say Soigno, which is, I'm very proud of Soigno, which was a Horizon 2020 project coming out of the European Union that is the beginning stages of building a microservices SCADA system. We do have the time to, we can't just rip SCADA out. We have to be able to kind of use it and begin to build the new parts to it. And so I think that that this is very exciting. I think we're going to have some very big news soon of a very, very large city in Europe that is going to begin adopting Soigno as the foundation. And the thing I would talk to that's about the TD interface and about how do we actually begin to build systems that communicate across transmission and distribution is a tool that's about to come in. That's a forecasting tool. It's a short-term forecasting tool and a flexibility tool. It's also used in the Netherlands. It's called GoPax. And we will rename it and give it a neutral name, not the name that's used in the Netherlands. And this tool actually enables a transmission operator and the distribution operators in a region or a country or a state to collaborate and coordinate with each other.
Wow. Thank you so much for that. I've really enjoyed this conversation, and I was just thinking as you were sort of sharing some of those details there, that you're going to have an amazing conversation with your grandchildren when the time comes. You're going to, you know, and
They're
you're going to,
1 and 4. They're
so
1 and almost 5, right?
so you're going to have an amazing conversation about what you're doing now to
I
shape their
hope.
future. So thank you so much for your time today. I've thoroughly enjoyed talking to you, and I hope it's been interesting to everybody that's listened. There's going to be some amazing takeaways from what you've said. So, you know, all I can say is massive thank you. I hope you stay safe and well.
You too.
And we'll follow this up with some of Lowell's lessons learned from this amazing conversation. So that's what will follow as the video is recorded. So thank you again, Shuli, and really
Thank
take care.
you. Thank you very much. It's been a wonderful talk. And I would love to add the last question. So maybe we'll come back and we'll start there, which is what can we do? And because I really want folks to join us. That's my call to actions. Come and join us. And, you know, we have to raise each other up, basically.
Fantastic. Thank you so much.
Thank you very much. Thanks.